Today we're going to be doing body composition, or a follow-up to last week's body composition, but obviously we're doing underwater weighing today. We spoke about it last week, but what are the 4 methods of body composition that we know of? There's a few others, but what are the 4 ones that we're utilizing here in this class? Skin folds, number 2. BIA, number 3. Which is the one that we don't do here? The DEXA, right? The DEXA being our gold standard. The one we will be doing that used to be the gold standard before the DEXA is this one, which we're going to have a full lecture on today, which is hydrodensitometry, underwater weighing. A fun fact, this guy was actually in this lab and was in that tank that you guys are going to go into. Back in 2006, the Miami Heat apparently, this used to be a myth, and then it was confirmed by someone who was actually here doing their PhD at the time, down at the med campus. Jesse, the other guy that teaches this class, he works down at the med campus, and he knew of like a mutual person that also did their PhD in this lab. And it was around this time, or around the time that he would have genuinely or technically been in here. And it was always a myth up to this point that we always just told students without actually knowing if it happened or not. But it was confirmed. He like asked him, he was like, yo, like, were you there when Shaq? And he was like, dude, I was there. So confirmed that Shaq has been in this room. Apparently, because Dr. Perry has been here for just as long. So you can imagine how that interaction went. Very interesting interaction. So Perry was apparently in her lab, and we had asked her about it after, and apparently just Shaq like walked into the room, like ducked under the door and like stood back up. And then it's just Perry and Shaq in the same room. Like, imagine that. Anyways, yeah, so confirmed. Pretty cool. You guys are going to share the same, not the same water, sorry, but the same tank. So again, just another basic introduction to what body composition is. It's the percent of body weight composed of fat and fat-free mass. Fat-free mass including bone, muscle, organs, and any other tissue related to that. And then fat mass just being everything that is essential or non-essential fat. So again, just think about this. Fat mass is everything fat related, whether it's adipose tissue, that kind of situation, viscera fat, subcutaneous fat, anything adipose tissue related. And then fat-free mass is everything that isn't fat. Yeah, pretty good, easy way to think about it. Then we get into what underwater weighing is. It was once the gold standard for body composition measurement, and it's based on Archimedes' principle of when submerged, the body is buoyed by a force equal to the weight of water displaced. And then just the idea of buoying. We had this discussion last semester. Is it buoy or how do you pronounce it?
We didn't have this discussion.
We had a discussion, because there was a lot of pronunciation discussions last semester. It's buoy, right?
What?
When you pronounce like a buoy. Is it a boy or a buoy? Buoy or boy? Buoy, right? To be like
But then it's buoyant.
buoy. Buoyant.
But buoy.
Buoyant and buoy.
Yeah.
Got it.
More buoyant?
Something is more buoyant, but when how do you pronounce buoy?
It's buoyant.
Oh, I thought we were okay.
How would I read this?
Wait,
Buoyed.
the body is
We're gonna go with buoyed. The body is buoyed by buoyed by a force equal to the weight of the water displaced. Where the understanding is that if someone has more body fat underwater, that there's gonna be more buoyancy, or that they're gonna float more, right? And that if someone has more muscle, or let's say less adipose tissue, they're gonna be more dense and they're gonna sink more, right? So we think about that inverse relationship again. Moving on, again, how hydrodensitometry works. Archimedes' principle is the loss of weight in water represents the volume of water displaced, right? So when you put something in water, there's going to be an equal amount of displaced depending on whatever the volume of that is. This nice little equation of how we achieve body density through this, right? So we go our weight in air, and then we divide that by the weight in air minus the weight in water, right? So understanding that the masses are going to be different there. And then we subtract the residual volume and divide by the water density, right? Which we have a temperature or a thermometer in the water, so we know what the temperature of the water is, because we know that the temperature of the water changes the density of the water. We'll get all of our metrics. We are going to have to use our estimation formula for residual volume because we weren't able to do the forced vital capacity test, right? But in a perfect world, if we were able to do the forced vital capacity, we would also be able to get our residual volume derived from that test and use that as a more accurate measure to get our residual volume, right? Residual volume is a very important, as we know, important limitation of this test. And again, the understanding that heavier weight in water is equal to a higher density and thus a lower body fat, and a lighter weight in water is equal to a lower density and thus a higher body fat. So It's very important you understand that relationship. And then residual volume, again, talking about it a little bit. Residual volume is the air remaining in the lungs after forced exhalation, right? It's there to be able to prevent any sort of lung collapse, which is good. We don't die. The importance of the accuracy of residual volume is that any trapped air in the lungs increases our buoyancy, right? Leading to an overestimation of body fat. If we have air in the lungs, so if you guys ever been to a pool and you want to sink to the bottom of the pool, what do? Right? And you used to go all the way to the bottom, right? If you wanted to float and you want to do like the whole like lying on your back, what do? You just breathe in and you become more buoyant. So that understanding is very important. And the biggest limitation of this test is going to be our subject compliance to how much they're actually able to push out. The more you push out, the better result you'll get on the test. Does that make sense? Okay. So calculating body fat using body density. We use either the Siri equation or the Brosick equation. We'll use both of them just to see the differences. Understanding that body density is the metric that we get from doing the test. And then we use body density into this formula, which is just a regression that was made from a bunch of different trials through research to be able to estimate our body fat percentage. For example, if somebody's body density is 1.05, by using the Siri equation, we would put that into the equation here, and you can see that their estimated body fat percentage is going to be around 12.9. Yep. Most body densities are going to be around that 1 mark, so if it's not, you did something wrong. Factors affecting accuracy. So fat-free mass density is assumed to be constant at 1.1 grams per milliliter, but it varies amongst individuals. Mainly because there are different variations in muscle mass and bone density amongst individuals in like terms of how dense the tissue actually is. And this leads to approximately about a 2% error, or plus or minus 2% error. And then residual volume, obviously that is going to be one of our biggest limitations. The next one is that underwater weight accuracy depends on the scale that's actually being used. In the old days, they actually used spring-loaded scales. And so what it would be is, there's a bunch of different forms of underwater weighing methods that people have used in the past. There's ones where people lie down in like a longer style tube. Like imagine you're doing an ice bath and you're kind of just sitting in like this tank, but you're on top of like almost like a cot, one of those beds, and you lie down on it. The difference between the force transducer and the spring-loaded ones. The spring-loaded ones are, if you've ever been to, I don't even know if this is the one they use, but if you go to like Publix and you see the scales that they use there, and if you like get on the scale and you like go up and down, it'll like, the thing will, those are the kind of the ones that were used. The issue with those, it is very sensitive to movement. Any sort of movement is obviously going to create that, and so it's hard to find a true peak because it's a value that's not really given to you. It's something that you got to kind of guesstimate, like, oh, it's somewhere between 3, right? That kind of situation versus a force transducer, which is what we're going to be using here, kind of gives you a true value. Think electric versus manual. And then the water temperature, right? So the density of the water changes with temperature, and then the corrections are made for water temperature and above 4 degrees Celsius, right? In terms of our relevance to exercise physiology, accurate body composition measurements help assess athletic performance. Depending on the sport, we want to have specific understandings of where our athletes are or where individuals are. There are many sports where body fat is a key performance indicator and could be one of the limitations as to why an athlete isn't performing as they should. So for example, a wide receiver, you don't want a wide receiver to have a high body fat percentage because fat don't fly. The more contractile tissue you have, right, the better. This is where kind of like contextual situations come into play and intuition on who you're working with and what that situation actually is. So yeah, it's a key performance indicator that we can use, and it's a metric that we're able to look at for that and assess for. Fat-free mass versus fat mass impacts metabolism, energy expenditure, and VO2 max, right? So another thing that we take into account. In terms of research and training, body composition assessments are critical for designing personalized training programs. So if we have, say, general population that comes in, again, like we were saying last week, one of the first things we want to do, because it's such an easy metric to get, depending on what assessment you use, but body composition is going to be a great tool for you to actually show someone that they're progressing in whatever program you're giving them, right? So if you're working with Gen Pop and you're able to give them body comp, they work with you for 8 weeks and you're able to give them a new body comp and they're leaner than before but have more muscle than before, you're going to make more money because it means you're doing a good job. Changes in body fat and muscle mass are key indicators of training efficacy. Ooh, vocabulary is on today. We already spoke about the potential sources of error, but incomplete exhalation, right? So not breathing out everything you have. Your prediction of residual volume, this is going to add errors to the body density calculations. Your measurement equipment, so depending on what scale you're using, it's going to affect the results. And then individual variation, right? So differences in muscle and bone density across individuals within the same population. or within different populations. Lab procedures. A lot of the stuff we talk about here isn't going to make a lot of sense until we actually do it. But the first thing we want to do is pre-weigh somebody, right? So we're going to weigh them outside of the water and determine their vital capacity using a spirometer if we had one, but we don't. So we're going to just estimate our residual volumes. Underwater procedures. So the subject is going to sit in the water, right? So you're going to see the PVC pipe chair that we have over there. You're going to sit in that chair. You're going to have your head right over the water, right? And then from there, you're going to exhale as much air as possible before the final weight measurement. So you're going to go like this. And stand perfectly still as you can, right? It's gonna be really hard to stand still at first. We're gonna give you a few tries to get familiarized with it. It is very stressful doing it for your first time. The more you do it, the more you kind of get used to like, oh, I'm drowning right now, but you'll be okay. And again, other limitations of the test is one of the biggest ones is just gonna be subject compliance. So like how well the subject is actually performing the assessment. If they're underwater and you're not standing still, our measurements outside is just gonna look like these crazy spikes, and it's gonna be really hard to find like a true value without artifacts being involved. Because for example, any movement that you do is going to affect like how much weight is being pushed. It's very sensitive, the machine. Right? So we wanna get as close to a true number as we can while filtering out any artifacts. So the more still that you are, the better the result will be, if that makes sense. Other thing that we need to do, and we're gonna talk about it over there, but as we're sitting down and we're actually taking the results, it's kind of important that you don't like jump out, because anything that you push out is obviously going to be pushed back into the chair. You're going to be drowning, I know. Try and relax, you know, smooth. You know, just breathe in, breathe out. Not underwater, but you know what I mean. And then our calculations. So we calculate body density using our weight in air, weight in water, and water density. And then our residual volume as well. And then we apply the Seerer-Brosick equation to estimate for body fat percentage, right? Which are right here. Questions on underwater weighing? Any questions? No questions. Body composition? Nothing. Nada. Zilch. Let's go have some fun.